One day, you will look up at the sky and realize that what you are seeing may have already ended. The sun will be there, the stars will be there, the galaxies will be there, but you will never be looking at them as they are now, because the universe never shows you anything at the moment it happens. Everything arrives late, everything is delayed, everything reaches you from the past, and the most disturbing part is this: you have called this now your entire life. If I asked you what time it is right now, you would have an answer immediately. You open your phone, look at the clock, and read the number. Easy. But now I am going to ask you a completely different question. What is happening right now at the far edge of the universe? There is not a single human being who knows the answer to that question. Not just humans. No being, no instrument, no technology can answer it. Because at the far edge of the universe, there is no such thing as now. Or more precisely, the thing you call now is only a small illusion belonging to your local region. You do not have to go very far to understand this. Go to your window right now and look at the sky. If it is daytime, you will see the sun. But know this: the light you are seeing left the sun 8 minutes ago. So when you look at the sun right now, you are actually watching a sun from 8 minutes ago. What is the sun like right now? You do not know. You cannot know. For 8 minutes, we have no information at all coming from there. So is this just an ordinary delay? No, that is not the most surprising part. Think about this. Let's say that at this exact moment, the sun went dark, exploded, or vanished. You would not know it for 8 minutes. For those 8 minutes, sunlight would keep reaching Earth. Plants would keep doing photosynthesis, birds would keep singing, and you might happily sip your coffee, look at the sky, and say what a beautiful day it is. The sun would already be gone, and you still would not know. This is not just one example. This is exactly how the universe sends information to you. Everything in the universe sends you delayed messages. Sometimes the delay is 8 minutes, sometimes 8 years, sometimes 8 million years. You know the stars you see when you look up at the sky at night? Not one of them is there now, in the sense you imagine. Some of them sent their light thousands of years ago, and that light reaches your eyes tonight. Some stars are so far away that by the time their light reached Earth, there were no humans here yet, maybe not even dinosaurs, and that light is now landing on your pupils. You are literally seeing the past. The past reaches you at the speed of light. But the real issue is this. You look at that star and say, that star exists, and yet that star may no longer exist at all. Maybe it exploded 1,000 years ago, collapsed into a black hole, and disappeared. But in your eyes, it is still shining, because the news of its death has not reached you yet. And according to the rules of the universe, that news cannot reach you faster than light. So you cannot avoid seeing that star. It feels as though the universe is giving you false information, but in reality, it is doing the best it can, because information cannot travel faster than light. Now stop for a moment and think about this. In daily life, we experience the idea of now as something solid, something real, something undeniable. You look at someone sitting in the same room as you and say that they are sitting there right now. Is that true? Yes, almost, but not completely. The time it takes for the light from them to reach you is so small, your brain cannot even notice it. A few nanoseconds. But in the rest of the universe, those nanoseconds turn into millions of years. It is very hard to truly grasp the size of the universe. When people talk about size, they always use numbers. Billions of light years, trillions of kilometers, things like that. But numbers do not create a real picture in the mind. So let's put it another way. If you compressed all of human history, the 5,000 years since the invention of writing, into 1 second, then crossing the Milky Way from one end to the other on that same scale would take about 20,000 years. And the Milky Way is only one of billions of galaxies in the universe. Now look at one of the farthest galaxies. If the light from that galaxy has only just started reaching you today, that means it is showing you what that galaxy looked like 13 billion years ago. What is that galaxy like now? Nobody knows. Maybe it is gone too. So ask yourself this: will we ever be able to know what the universe looks like right now in its entirety? No, never. Because information from different regions of the universe reaches us at different times. When we look at the sky, we are actually seeing a collage made of different eras stacked on top of one another. The nearest stars show us a few years ago. The distant galaxies show us billions of years ago. They all appear at once, but they come from different times. Scientists call this the light of the past. Telescopes are really time machines. The deeper we look into space, with Hubble or with James Webb, the farther back in time we look. Right now, we have images of galaxies from billions of years ago. We can see periods very close to the beginning of the universe. But all of that is the past. We never see its current state. And now we come to the strangest part. It is not only distance, movement itself also affects time. Einstein discovered this more than 100 years ago, and every experiment since then has confirmed it. For things moving fast, time passes more slowly. This is not just a theory, it is a proven fact. Our GPS satellites have to account for it, or navigation systems would drift more and more every day. But let's set that aside for a moment, because what I want to tell you is even more basic, even more fundamental. What do we mean when we say now? You have probably never taken that question this seriously before. Now, this moment, the slice of time you are living in. In Turkish, in English, and in every other language, the idea feels natural, simple, obvious. But the physics of the universe says that the thing called now does not actually have a universal meaning. Your now is not someone else's now. Let's make that concrete. Imagine that at this exact moment, two events happened at the same time. An earthquake struck Earth, and at the same moment, a huge eruption happened on the sun. You say those two events are simultaneous, but for an observer moving at a different speed and in a different direction, those two events are not simultaneous. One happened first, the other happened later. Which came first? Which came second? That depends on the observer's speed and position. Both observers are right. Neither one is wrong. The universe has no official clock. The universe has no now. When people first hear this idea, it causes a kind of shock. What do you mean? There is no absolute time for everything. And it turns out, there is not. In Newton's time, people believed that time flowed the same everywhere. They imagined a universal clock in the sky. Absolute time. Absolute now. Einstein overturned that idea completely. Time is part of a flexible structure, interlocked with space, and that structure can be bent, stretched, and slowed down by matter and energy. When you wake up in the morning and sunlight touches your face, that light left the sun 8 minutes earlier. Before it reached Earth, it crossed the cold and silent depths of space. No air, no sound, no resistance. It came straight to you. and you feel that light. But what you are really feeling is a moment from 8 minutes ago. Let's go even farther. When you look at Sirius, one of the brightest stars in the night sky, you are seeing light that began its journey about 8.5 years ago. Where were you 8.5 years ago? What were you doing? Who were you trying to become? That light set out during that time and reached you only now. It is as if the universe has sent you a postcard from that period. If we go farther still, some stars in the constellation Perseus are a few hundred light years away, which means the light coming from them began its journey during the time of the Ottoman Empire. Maybe Columbus had not yet reached America. Maybe the Renaissance was only beginning to bloom in Europe. The light from that historical era is looking at you tonight. The light of the age you read about in history books is literally in your eyes. And then there is the Andromeda galaxy, 2.5 million light years away. When the light that is reaching Earth from there began its journey, Homo sapiens did not yet exist on Earth. Our ancestors may not even have known how to use fire. And the photons that left that galaxy are landing on your pupils tonight. A light older than human history is touching the cells of your retina today. That is why astronomers describe looking into space as looking backward. Every telescope is also a time machine. The more powerful it is, the farther back it goes. Right now, the James Webb Space Telescope is sending us images of galaxies from the first few 100 million years of the universe. The universe is about 13.5 billion years old, and we can look back almost to the beginning. But those images are not what those galaxies look like now. They are photographs of what they looked like then. So what would you do if you wanted to see the universe as it is right now? If you could travel faster than light, you could watch the universe in real time. But that is impossible. The laws of physics do not allow it. The speed of light is the speed limit of the universe. You cannot go beyond it. And that limit keeps you permanently isolated from the universe in a very deep way. The universe is out there, existing, moving, changing, and you are receiving only a delayed signal. When you open your window at night and look at the stars before going to sleep, what do you feel? Maybe peace, maybe curiosity, maybe a sense of loneliness. But now you will feel something else too. Those stars are sending you greetings from the past. A light that burned thousands of years ago was traveling toward you that night, and you were standing there without ever realizing it, as a witness watching the past. In the next part, we will go deeper still, not only into the delay of light, but into how time itself bends, how speed and mass change time, and why the idea of now does not actually have a universal meaning through Einstein's astonishing discoveries. Because this story is only just beginning. Picture a train cutting through the dark long after midnight. From the outside, it looks almost unreal. A strip of moving metal, a few dim windows, the whole thing rushing forward as if the night is letting it pass for a moment and then swallowing it again. Now place a single flash of light in the exact middle of one carriage. Anyone sitting inside would describe the scene in the most ordinary way imaginable. The bulb flashes, the light leaves the center, and because the front and the back are the same distance away, both ends of the carriage receive it together. Nothing about that feels surprising. Everything inside that frame looks balanced. You could explain it in one sentence and move on. Someone standing beside the tracks cannot move on so easily. From the platform, the train is not a still room with seats and doors. It is a moving object, and while that flash is traveling through the carriage, The rear of the train is coming toward the light, while the front keeps pulling away. That means the light does not meet both ends under the same conditions. One end approaches the signal, the other makes the signal chase it. As a result, the observer outside says the rear receives the flash first, and only after that does the front. The strange thing is not that two people describe the moment differently. What really matters is that both descriptions are valid. Nobody has misunderstood the situation. Nobody is hallucinating. Nothing fake has been inserted into the scene. Reality itself is allowing both answers. That is where relativity stops feeling like a clever trick and starts becoming unsettling. Most of us grow up assuming that if two careful observers disagree, one of them must eventually give way. We trust the idea that behind every disagreement, there is a final version of events waiting to be uncovered. Einstein showed that this trust has limits. When motion becomes part of the story, the universe does not always reward us with one shared verdict about what happened at the same time. That train thought experiment matters because it breaks a habit of mind that feels almost too basic to question. People rely on the word now as if it were the safest word in language. You say now and assume the meaning stays intact no matter how far you stretch it. A room can share a now. A street can share one too. Earth makes it feel easy. Once distance and speed start to matter, that comfort begins to fail. At that point, the present stops being something universal and becomes something local. Einstein did not simply add a few complications to an old picture of time. He dismantled the old picture altogether. Instead of one invisible cosmic clock ticking above everything, there are observers moving through reality in different ways, and each one cuts up time differently. That is not poetry. Physics has to take it seriously because nature does. Let the scale grow for a moment. A volcano erupts on Earth. Far away, near Jupiter, an asteroid plunges into the giant planet. From here, you might say both events happened together. The sentence comes naturally because your mind wants to place them on one timeline. Now put an observer in a spacecraft moving through the solar system at tremendous speed. That observer will not necessarily keep those events side by side. Depending on the direction of travel, the eruption may come first. A different spacecraft passing another way can reverse the order. Nobody involved is breaking the laws of physics. The laws themselves are what allow this. Human intuition rebels at that point because it wants a final answer hidden somewhere underneath all perspectives. Surely one event really came first. Surely the universe itself knows which order is correct. Relativity refuses to hand over that kind of comfort. For events separated enough across space, there may be no universal ordering that every observer is forced to share. The moment you accept that, the meaning of now begins to collapse. Daily life protects us from feeling how strange this is. Nothing in an ordinary conversation prepares you for it. Cars are slow, rooms are small. Human beings evolved in a world where the relativistic differences between observers are so tiny that they disappear into the background. That is why common sense feels Newtonian. Time looks absolute because our environment is too gentle to expose its deeper structure. Physics becomes powerful precisely where common sense becomes lazy. Small differences that mean nothing to the body can mean everything to reality. This is also why relativity is not just a strange philosophical upgrade. Technology runs into it directly. GPS satellites are the most familiar proof. Those satellites are moving quickly around Earth, and they are also higher up in a weaker gravitational field than we are. Both facts matter. Speed changes how their clocks compare with clocks on the ground. Gravity changes the comparison too, but in a different direction. Engineers do not have the luxury of treating those effects as interesting trivia. Signals from those satellites travel at light speed. Once light enters the calculation, Even tiny timing errors become large spatial mistakes. Ignore the corrections, and your location begins to drift. The map still looks polished, the route still appears smooth, the interface still behaves as if it understands the world. Behind that calm surface, the numbers have started to slip out of step with reality. A navigation system only works because relativity is quietly built into it. That fact is worth pausing over. One of the most unsettling discoveries in modern science now lives inside the phone in your pocket. You tap a screen and ask where you are, and the answer depends on a universe where clocks do not agree perfectly. Time feels simple to the user because the machinery beneath it has already accepted that time is not simple at all. So what changed at the deepest level? Einstein's most important move was not merely to say that clocks behave oddly. He showed that space and time belong to one structure. Space-time is the name we give to that structure, and the name matters because it forces us to stop imagining space as one thing and time as another. There is no empty stage waiting passively while matter moves across it. The stage itself responds. Mass bends the geometry around it. Energy shapes the structure too. Gravity is no longer an invisible pull acting across empty distance. It becomes the result of moving through curved space-time. That shift changes the status of time immediately. If time belongs to the same structure as space, then gravity does not merely steer objects, it alters the rate at which moments unfold. A clock deeper in a gravitational field runs more slowly than one farther away. Near Earth, the difference is tiny. Tiny is not the same as unreal. Experiments have measured it. Precision instruments have confirmed it. Airplanes carrying atomic clocks have demonstrated that motion and gravity leave subtle signatures in time itself. Once you know that, the universe stops looking like a place where events happen inside time. It starts looking like a place where time is one of the things being shaped. That is a disturbing thought in the best possible way. People like to imagine time as the one stable background that reality cannot tamper with. Relativity says no. Motion touches it. Gravity touches it. Position matters. The rate at which time passes is not sacred. Push the idea far enough and you arrive at the edge of a black hole. Nothing about that environment behaves politely. A person hovering close to the event horizon would be living in conditions where gravity has become extreme enough to tear everyday intuition apart. Someone watching from far away sees a very peculiar scene. The closer that person gets to the edge, the slower they seem to move. Light from them stretches toward longer wavelengths. Signals arrive more weakly. The whole image begins to fade and stall. To the distant observer, it can look as if the black hole is smearing time itself across its boundary. Yet that is not what the person near the black hole feels. Local experience continues in the ordinary way. A thought follows another thought. A hand still moves when they decide to raise it. Nothing in their immediate awareness announces that the rest of the universe thinks their time has nearly ground to a halt. The contrast is severe because both experiences are legitimate within the same physics. No hidden referee steps in to declare one clock more real than the other. That refusal is exactly what makes relativity so hard to digest. It asks us to surrender the fantasy of one privileged timeline. Near a black hole, the surrender becomes dramatic. A short interval for one observer can correspond to something vastly longer elsewhere. The mathematics does not add that effect for drama. It falls naturally out of curved space-time. Black holes are not only places where light struggles to escape, they are regions where the meaning of when becomes violently local. Return to the original question after that. If time itself depends on motion and gravity, what would make one universal present possible? Nothing would. A shared now across the whole universe would require a shared rhythm. Reality does not provide one. Earth gives us the impression that time is steady because the conditions here are mild enough to keep the differences small. That impression is useful. Human life depends on it. Hours feel like hours. Morning arrives. Bodies follow cycles. Clocks around us agree closely enough that we build civilization on top of that agreement. Cosmic truth is not required to preserve local comfort. Elsewhere, the story changes. Near compact stars, around black holes, or aboard objects traveling at extraordinary speed, time pulls away from the familiar pace we trust. Once the pace changes, the idea of a common present begins to look less like a fact and more like a habit of thought. This is where the block universe enters the discussion. Some physicists describe space-time as a four-dimensional whole that contains what we call past, present, and future. That language feels cold the first time you hear it. Human beings are built to feel time flowing. Memory lives behind us. Expectation lives ahead. The present seems to move like a spotlight. The block view asks whether that feeling belongs more to conscious experience than to the large-scale architecture of reality. In such a picture, the past is not destroyed simply because you can no longer return to it. It remains part of the total space-time structure. The future also stops looking like an empty room waiting to be furnished. Instead, it becomes another region of that same structure, not yet experienced by you, but not therefore non-existent in any simple sense. This does not automatically solve the question of free will. It certainly does not make life emotionally easier. What it does is force a sharper question. If the universe is not organized around one moving present, what exactly are we experiencing when we feel time pass? Maybe the flow belongs to us. Maybe the structure belongs to space-time. Maybe consciousness and cosmic geometry are not describing reality from the same level. Even people who reject the block universe still have to admit that relativity made the old picture of time dangerously fragile. Think again about enormous distance. A star explodes near the far reaches of the observable universe. Was that explosion simultaneous with this very moment on Earth? The urge to answer yes or no is strong. Neither answer captures what relativity is telling you. The event has a local time where it happens. For you, it has not entered experience. Its light is still traveling. Its information is still trapped inside a journey that will last longer than civilizations. By the time that signal reaches Earth, whatever now means for us may be gone. That distant explosion can be real without belonging to your present. This is where the idea of the light cone becomes indispensable. Picture your current position as a point in space-time. From that point, one cone opens backward. Everything inside it consists of events whose signals could already have reached you. Sunlight from minutes ago lives there. Starlight from years ago lives there. Galactic light from deep history lives there too. Another cone opens forward. That one includes the places your influence could eventually reach. A radio transmission leaving Earth enters that cone. Light from a screen does too. Anything that begins here and moves outward under the laws of physics is confined by that future boundary. Outside those cones lie events that may be perfectly real and still disconnected from your present moment. They cannot touch you now. You cannot touch them now. The universe is not only vast, it is selectively connected. That is what the light cone teaches with brutal clarity. Reality extends farther than your reach. Knowledge extends only as far as signals can travel. At first, this sounds restrictive. With a little time, it becomes clarifying. Your world is not the whole cosmos at once. It is the portion of the cosmos that can actually communicate with where you are. Silence then stops meaning emptiness. Silence begins to mean distance without causal contact. That distinction matters. Now imagine intelligent beings on a world billions of light years away. Suppose they own telescopes far beyond anything we can build. They turn those instruments toward Earth. What appears in their data is not humanity. No cities are glowing there. No satellites cross the sky. Depending on the distance, they might be looking at a young planet still settling into itself. Maybe the oceans have only recently formed. Maybe the surface is barren. Maybe life has not yet done enough to announce its presence. Meanwhile, we could be looking toward them and making exactly the same mistake in reverse. Each side studies the other as delayed evidence. Neither side sees a living present. Two civilizations could exist in the same universe and still remain out of sync so completely that direct coexistence becomes meaningless. That is one of the deepest sources of cosmic loneliness. The loneliness does not come only from scarcity. Distance is enough. Time does the rest. A message sent across such scales stops being conversation in the ordinary sense. It becomes an exchange between eras. By the time a reply returns, the world that asked the question may be unrecognizable. History might have folded over itself several times. Civilizations may rise and vanish in the gap between one sentence and the next. Yet none of this should be taken as a reason to feel small in a cheap way. The lesson is not that human life is worthless against cosmic scale. Relativity points towards something subtler. Your local present is precious precisely because it is local. You are here now on Earth, breathing in air that reaches you without billion-year delays, living among signals that can actually arrive in time to matter. Sunlight touches your skin within minutes. Voices reach you fast enough to answer. A hand can be held before history turns to dust. That kind of nearness is rare. The universe does not offer it everywhere. There is another shock nested inside that thought. Your body is made from ancient material. Carbon, oxygen, iron. All of it was forged in stars long dead. The matter composing your present life comes from a history older than Earth itself. So even while you inhabit a warm local now, you are physically built out of deep time. The universe took billions of years to produce the conditions under which a creature like you could ask what now means. That is not a sentimental statement. It is a physical one. A cosmos that bends time, delays light, and refuses to give everyone one shared present. Also produced minds capable of noticing the refusal. That may be one of the strangest facts of all. In the next part, the picture grows even larger. We will leave trains and black holes behind for a moment and look at the sky itself, because the deepest shock is still ahead. What seems like one live cosmic scene is not live at all. The universe above you is layered with different ages, different delays, different histories arriving together in the same darkness. Once that sinks in, the night sky will never look innocent again. Now let's take this out of the human scale and spread it across the entire universe. Because the collapse of the concept of now is not only about seeing stars with a delay. The real, larger issue is this. You cannot draw one single cosmic map that shows the entire universe at the same time. Such a map is physically impossible. If you want to call one point the current state of the universe, you would need to know the condition of every galaxy, every star, every black hole, and every source of light at that same moment. But the universe does not give you that kind of information. No telescope can do this. No computer can calculate this. No civilization, no matter how advanced, can take a shared present-time photograph of the entire universe. Because information cannot travel faster than light. And the speed of light is not only a speed limit, it is also the information limit of the universe. It determines what can become part of your reality, what you can see, what you can measure, what can affect you, and what will remain separated from you forever. That is why, when you look up at the sky, what you see is not the current state of the universe. What you see is a stack of signals from different times, layered into the same sky. The moon comes from about 1 second ago. The sun comes from 8 minutes ago. Sirius comes from 8.5 years ago. Andromeda comes from 2.5 million years ago. Distant galaxies come from billions of years ago. They all appear in the same night sky, but they do not belong to the same time. The sky looks like a landscape, but it is not really a slice of time. It is more like a giant archive, where light from different ages of the universe gathers together. And inside this archive, there is no single page called now. This is where one of the most important boundaries in cosmology enters the story, the observable universe. The universe is about 13.8 billion years old, but the edge of the universe we can observe is about 46 billion light-years away. At first, this sounds impossible. If the universe is 13.8 billion years old, how can we see something 46 billion light-years away? The answer is that the universe expanded during that journey of light. While light from a distant galaxy was traveling toward us, the space between that galaxy and us kept expanding. The light traveled, but the road itself also grew. That is why the most distant regions have been carried much farther away than the time it took their light to reach us. So the farthest things we observe are not only far away, they also come from the youth of the universe. Telescopes like James Webb do not show us today's galaxies. They show us how galaxies looked during the very early stages of the universe. Some of the galaxies we see in those images are no longer the same galaxies. Maybe they merged. Maybe they broke apart. Maybe the generations of stars inside them have already changed. Maybe the black holes at their centers have grown. But we do not know their current state. We cannot know, because their present-day light has not reached us yet. And for some of them, their present-day light will never reach us at all. This is where things become even stranger. The universe is not only expanding, its expansion is accelerating. Because of this acceleration, some galaxies are moving away from us in such a way that even though we can see them today, the light they emit in the future will never reach us. This is an extremely strange situation. You can see something through a telescope right now, but you cannot access its future. You have caught it in the past, but you have lost the right to watch what happens next. It is as if the universe has shown you a very old frame from a film, but has closed the rest of the film forever. This is close to the idea we call the cosmic event horizon. Black holes have an event horizon. Beyond that boundary, no light can return. Cosmology has a similar kind of boundary. Some regions can no longer form a causal connection with us. They may exist inside the universe. They may have their own stars, planets, black holes, and perhaps even civilizations. But they cannot send a signal into our future, and we cannot reach their future. At this point, the entire universe and the universe available to us stop being the same thing. We do not live inside the whole universe. We live inside the part of the universe that can send signals to us. We can call this our light cone. Our past light cone contains every event that can reach us today. Our future light cone shows the regions that something we do today could affect in the future. Everything outside that cone remains unmeasurable, untouchable, and unverifiable for us. We can imagine what might be there. We can build mathematical models. We can create theories about the larger structure of the universe. But where direct information cannot reach us, physics becomes silent. This silence is not emptiness. It is the boundary line of the universe. Now let's look at the oldest light, the cosmic microwave background radiation. This light was not released immediately after the Big Bang, but about 380,000 years later, when the universe became transparent. Before that, the universe was a dense, hot, opaque plasma. Light kept colliding with particles and could not travel freely. Then the universe cooled. Atoms formed. For the first time, light could travel across long distances. Today, we receive that light from every direction, as a faint, cooled glow that fills almost the entire sky. This light gives us the baby picture of the universe. But again, pay attention. This is not watching the beginning of the universe live. It is an extremely old signal, coming from a very ancient surface. The cosmic microwave background is one of the oldest forms of light we can see, but we cannot directly see what came before it, because the earlier universe was closed to light. So there is a visibility limit in the past of the universe too, not only in distance, but also in time. There is a curtain. This curtain weakens the idea of now even more, because the universe does not reveal itself to you as one complete piece. It opens layer by layer. The nearby universe looks more recent. The distant universe looks older. The oldest light shows the youngest universe. And when all of this arrives in front of your eyes at once, you think you are seeing one sky. But what you are looking at is a layered map of cosmic time. That is why the question, what is happening in the universe right now, is much harder than it seems. On Earth, you can say now. In a room, you can say now. Even inside the solar system, with small corrections, you can build a shared time system. But when you move to the scale of the universe, that word breaks apart. As distance increases, what you call now becomes a local measurement. When speed enters the picture, it shifts even more. When gravity enters the picture, it bends even more. And when expanding space enters the picture, some regions leave your time story completely. Think of a galaxy. Today, you see it as it was 12 billion years ago. In its own local time, that galaxy may now be in a very different stage. Maybe star formation has stopped. Maybe it has merged with other galaxies. Maybe the black hole at its center has consumed the matter around it. Maybe it no longer even resembles what we understand as a galaxy. But in your sky, it still stands as a young, bright, distant structure. Because you are not in contact with its today, you are in contact with a very old light record. This is both the power and the limit of astronomy. Astronomy shows us the past in astonishing detail, but it does not give us the real-time state of the universe. Telescopes are not live streaming devices. Telescopes are time machines that capture old information carried by light. And the farther you look, the farther you move away from the present. Now let's go into the future. In the very distant future, the Milky Way and Andromeda will have merged. The galaxies inside the local group will remain gravitationally connected, but most of the more distant galaxies will slip beyond the visible horizon because of accelerated expansion. Imagine an astronomer living hundreds of billions of years from now. If thinking beings still exist around stars at that time, they may not see the rich landscape of galaxies that we see today when they look up at the sky. They may see a much darker, much emptier universe. Distant galaxies may already have become invisible. The cosmic microwave background radiation may also have stretched and weakened so much that detecting it could become almost impossible. So future astronomers may have a much harder time understanding that the universe is expanding than we do. We are living in a very special window of cosmic history. The universe is old enough for galaxies to have formed and become observable, but it is not so old that everything has escaped beyond the horizon. This makes the present moment special, not philosophically, but scientifically. We can still receive a great amount of signal from the universe's past. We can measure the cosmic background. We can see the distribution of galaxies. We can follow the traces of dark energy. We can approach the first stars and the first galaxies of the universe. But this window will not stay open forever. As the universe expands, information will become thinner, signals will weaken, light will redshift, distant regions will disappear from the sky, and cosmic memory will slowly retreat into darkness. So when we say, "There is no now in space," we are not only talking about a strange Einstein idea. We are talking about how the universe can be seen, which information can arrive, which regions are lost forever, and how cosmic history can only be read in fragments. If there is no now, then the universe is not one single stage. The universe is a vast structure that opens to every observer through a different layer of time. Your sky is the universe that can be seen from your position and your time. The sky of an observer in another galaxy is an entirely different time map. They also look into the past. They also cannot see certain things. They are also trapped inside their own light cone. That is why, just as there is no absolute center in the universe, there is also no absolute now. Every observer looks through their own cosmic window, and every window shows only the reachable part of the universe. Maybe this is the biggest result of this video. The universe never gives us all of itself. It only gives us what can reach us. Everything else remains behind the speed limit of light, the expansion of space, and the curved structure of time. That is why the night sky is not just a dark space filled with stars. It is the part of the universe that has managed to reach us. Every light you see is information that has traveled through time to arrive here. Some began their journey a few minutes ago. Some began millions of years ago. Some began when the universe was still young, and all of them seem to burn in your eyes at the same time. But now you know. They are not simultaneous. They do not belong to the same now. They are not tied to the same universal clock. There is no shared now in space. There is only the past that light has been able to bring, and a future that has not arrived yet, and maybe never will. So the next time you look at the stars, remember that what you are seeing is not a current universe. What you are seeing is the thinnest layer of cosmic history that has managed to reach you. And that layer continues to glow silently inside the darkness.